Okay, Esther, thank you. Thank you very much. Yes, let's go to the first slide. Okay, well, thank you, everybody, and good morning from Holland. Good afternoon in Australia. Thanks for joining the webinar on vacuum cooling. Well, as you all know, in the food industry, time and temperature are crucial in the operation, and speed is essential. And traditional cooling methods are taking too long, and companies are nowadays looking for alternatives to cool quicker, to speed up kitchen flows, improve food safety. And here is where vacuum cooling is offering a game-changing solution. Weber, we are a company located in the Netherlands, and we are focused exclusively on offering vacuum cooling solutions and vacuum freeze drying. We started back in 2011, and we started focusing on the market for fresh products, offering solutions to vacuum cool products like leafy vegetables, mushrooms, herbs, flowers. And with our knowledge, we, after that, entered the market for the bakery and the hot food. And since 3 years, we're also offering solutions for vacuum freeze drying. So we have 3 divisions: the division for fresh and food. We have the division of bakery with our also in-house master bakers. And we have the division of vacuum freeze drying. Our headquarters are in the Netherlands, where we have our sales or main sales office administration, where we design the systems, and we operate worldwide. And this means that we work together with partners as much as possible. And in Australia, we work with Heuch and with Ester. Okay, Esther. So, yes, we have production facilities. Our headquarters are in Holland, but our main production facility is in China, where most of our systems are made. And we have a small factory in Hungary for some smaller systems. So mainly our biggest, our main factory is in China. Okay, Esther, let's continue and let's start now talking about vacuum cooling and how does vacuum cooling work? Because you will see that you will not use any cold air or cold water to cool. It's just the process of or using pressure. Now, the table you see here is actually what will happen in the vacuum chamber to cool. There is a direct relation between the level of the pressure and the boiling point of water. At sea level, the ambient pressure is 1000 millibar, as you can see. And if you start boiling water, it will boil at 100 degrees. If you go lower in pressure, so if you go up to Mount Everest, pressure will be lower and you will be able to cook or boil water much faster. And you can go up or go down in pressure to the 6 millibar, which will equal the 0 degrees. So this table is actually what I always call the magic table. And this is what's happening in vacuum cooling process. So if we go to the next slide.
Yeah.
Here. Now, how does it work? Here you see the vacuum chamber. And say you're cooking rice and you want to cool it very quickly. You take out the rice and it will be let's stop the video 1 second, Esther.
Mm-hmm.
So you take out the rice, it's very hot, 80 degrees, say. You place it immediately in this vacuum room. You close the door. Now here at the right, you see a vacuum pump, which will start taking out the air of the room. And as it takes the air out of the room, the pressure will start going down. And you see that here in the pressure gauge. It's going down, down, down. Now, when the pressure reaches the temperature of the rice, and say the rice is like 70 degrees, like it's around 450 millibars, 500 millibars, at that moment, because of the pressure, a bit of the moisture on the surface of the product will be forced of the water will be forced to boil and evaporate. And this process of evaporation, because of the process of evaporation, the heat is being taken out of the product. Now, if you continue to lower the pressure, because the vacuum pump continues to take out the air, you continue to lower the pressure, you also continue the process of evaporation and you continue the cooling process. Now, you can go all down to the 6 millibar, which means 0 degrees, but you don't need that. So you stop at the temperature you desire. You can stop at 40 degrees, 30 degrees, but you also can go down to 5 degrees. Now, the moisture you saw in the room needs to go somewhere, needs to be evacuated. So at the side of the room, we have what we call a heat exchanger. The heat exchanger is filled with glycol mix. To go to low temperatures, the glycol mix will need to be at -5. So what happens is that when all the moisture or the heat is released from the product, it's directed to the heat exchanger. Esther, maybe you can run again the video. It's directed to the heat exchanger. This heat exchanger absorbs all the moisture so that all the moisture does not go through the vacuum pump, because the vacuum pump does not like moisture. So it's absorbed by the heat exchanger. And at the end of the cycle, this is recondensed, the moisture is recondensed, and at the end of the cycle, the water will be, there's a drain here at the bottom, and the water will flow through the drain. Now, at the end of the cycle, the valve of the vacuum pump will be closed, and we have an inflation valve, which will blow or flow, put in air again in the room. And with this, the pressure will go up again to the 1000 millibar. And at that moment, only at that moment, you will be able to open the door and take out your product. Now, we haven't showed, no, go back. We haven't shown here a chiller. It's not on the drawing, but to complete the process, after the product has been cooled down, this glycol mix has been warmed up by around 5 degrees, a delta 5 or 4. So this glycol is being sent through a pipe to an independent chiller, and the chiller will cool down again this glycol to again -5 and send it again back to the heat exchanger for a new cycle. Now, the great thing of vacuum cooling is that you will cool the product from inside out. So very different than a blast chiller or conventional cooling method. Here, you don't blow air trying to cool the product from outside to the inside, which does not give you any guarantee that the core of the product is really cold. But here you have the guarantee that because you are cooling from inside out, all the product will be evenly cooled. And it doesn't matter if your product or your tray is at the top or in the middle or below, the pressure is the same. So the cooling is the same, it's uniform. And that's one of the main advantages of vacuum cooling. Now, how fast is this process? Depends on the end temperature you want to reach. If you want to cool, for example, rice to 30 degrees, you're talking less than 10 minutes. You're ready. The lower you want to cool, the more time it takes, but it will never take more than, say, 25 minutes or max 30 minutes, depending on the product. So it's really a huge difference with the conventional cooling methods that take for hours. So a big advantage is uniform cooling and a very, very fast cooling time. Okay, Esther, next one. So what we say here, what bottlenecks can vacuum cooling solve? It can solve a very important one, which is food safety, because you are passing the danger range of the high temperature. You're passing this very, very fast in minutes. So you're limiting the risk of contamination. You are improving, you're increasing the processing time. So if you cool in half an hour, you can speed up packaging. You can speed up the whole process in your kitchen floor. And then you have also the floor space constraints. You have a small system where you can cool very fast and increase your productivity. And even you may have also smaller cooling rooms or blast chillers, because with vacuum cooling, one of the big advantages also is you will be entering cooled product into your blast chiller or cold room storage. And another big advantage of this process is what we say the energy saving, because you're entering cold product every time in your cold room, your cold rooms will work much more efficiently. But on the other way, also vacuum cooling is like about 60 or 70% more energy efficient than a blast chiller. A blast chiller will work for hours. It has bigger compressors, while a vacuum cooling system uses a small pump, a small chiller, and what you do is you have a big cold trap which captures all the moisture, and this makes the whole process much more efficient. Okay, next one. So for which products can you cool with vacuum? All products that contain water and that have an open structure can be cooled under vacuum. So actually, most of the food products. You see here some examples. You see steak, chicken, pasta, vegetables, rice, lasagna. Which products you cannot vacuum cool? Those products that are airtight, like a sausage. Why? Because the moisture cannot get out of the, say, of the packaging. It has to have an opening to release the heat. So airtight packaged products do not cool under vacuum. Also, very liquid products with low viscosity will not cool well because they will splash because of the pressure. So soups are not suitable. And very, very liquid sauces, also difficult. A more compact sauces are possible. And one of the things that customers are doing also is to avoid the splashing. You can put a lid on the trays with some holes, which will avoid the splashing, and it's an excellent solution. Also, fried food is also very, very suitable. It's very interesting to see that after the vacuum cooling, they are more crispy because at the outside, they lose more moisture and it will become more crunchy, the product, and it will stay also more crunchy as long as it's not packaged. So these are all the products that you can vacuum cool. And of course, there are much more products. Maybe we haven't done any testing, and that can be vacuum cooled under vacuum. But these are all products that have already been tested, and all these cool in less than what we say 30 minutes. Okay, next one. So what are other benefits that we haven't mentioned? One of the interesting benefits is that you can cool, or you can in your racks you can put more trays, leave less space between the trays, because you don't need the airflow to cool the product, because as we explained, you are cooling from inside out, so you can place more trays in your rack. The flexible loading, that means we design systems adapted to the size of the trolleys you need. So it doesn't matter if you have wide or smaller trolleys, high. We adapt and we make the rooms according to your request. We talked about reducing the risk of contamination, because as explained, you pass this danger zone between the 70 and 60 degrees very, very fast. And this will help you also prolong the shelf life. How long? I mean, there is no definite number to say 2, 3, 4 days, but it depends on the product also and on the moisture content, but definitely it will help on mitigating the risk of contamination. The uniform cooling, we explained why, because of the process of the equal pressure in the room. And we have, well, the low operation cost. It's vacuum cooling is very, very energy efficient if you compare it to a blast chiller, because of the chiller, the cold trap, and the very fast cooling times. Okay. Now we want to show you some case studies so that you get a better impression of how does it work at customers. Eetgemak is a Dutch company. It's a very big company that offers ready meals for the healthcare sector, institutional market. And they had some issues with their cooling time, and they wanted to increase capacity. And they have started this year using vacuum cooling, and they have seen that their cooling times have been reduced enormously. They were cooling before during 4 hours, all the products in the blast chillers, and they're now cooling in 20 minutes. That's what they're using, 20, 25 minutes. So they have increased really also their kitchen flow speed, and their throughput has increased. They have also noticed that the packaging and the flow is much faster. They don't have to wait 4 hours before another process of packaging. So shifts are shorter, which are huge benefits. And we want to show you now a short video where you can see the system and you can hear from the operation manager, Erwin, what his experience has been with vacuum cooling. Esther, I don't hear any sound.
Is that better?
No,
No?
I don't hear it. I don't know.
No, I'm not getting any sound either.
No,
Okay,
no.
just one second, please. Only 1 second. Oh. Okay, please let me know if this works. Can you hear it now?
No.
No?
No.
Okay, well, apologies to all of the attendees about this. I am using another system today. Just 1 second, please. I'm just gonna try something else. Hmm. Um, Well, I am sorry. I don't know if I'll be able to fix this, and I don't want to keep everyone waiting. So basically, you will see anyway the operations at this company. The testimonials, what he's saying is basically what we have on this other slide. So we will be sharing this deck after the presentation has finished. So yeah, he basically says that they were cooling in 4 hours. Now it takes them only 20 minutes, and they have boosted their production capacity. But at least you will get a chance to see how it is working for them in their factory and their flow. So I'll just play the video now.
So they are cooling, this is couscous, they're cooling couscous, they're cooling vegetables, they're cooling rice, they're cooling baked potatoes. So they're cooling a wide variety wide range of hot food.
Favor vacuum cooling because our blast chillers don't cool down the product fast enough. So we want to use the vacuum cooler as a way to cool our product even faster, and we've changed it from 4 hours cooling in the blast chiller to about 20 minutes in the vacuum cooler.
So there, what he was saying was that their main
Hear that?
was cooling faster. You can hear me, Nick?
Yeah,
I
yeah.
can hear the voice on the video. I don't know if everyone else could, but
Yeah, the voice
Oh, you
can be
did?
heard.
Oh, fantastic. Okay, I'll keep playing then. Great.
Yeah, it helps us a lot in increasing the production capacity because we can give the product faster to our packaging department. That's usually it took about 4 hours, and now it only takes 20 minutes.
Okay, so this was our Dutch customer using a vacuum cooling system. It fits 2 trolleys, and well, as you see, cooling a lot of products. We have another case study. In China, vacuum cooling is actually very much used and much more known, the technology, than in other regions in the world. Many airline catering companies use it to cool. We also have a video here. What they, China Eastern Airlines, when I visited the company, what I saw is they have a fixed time of cooling, 20 minutes, doesn't matter what product, they just cool in 20 minutes and then they process. Some products maybe come at 10 degrees, other maybe at 8. But for them, it's important the time that fits their process in the whole operation in the kitchen. So in the next video, you will see, well, this is their very big kitchen. Also cooling, they cool everything. They cool the pictures you saw, the steak, they cool baked duck, chicken, fish, salmon. The vegetables, they boil in water with a bit of oil. And after vacuum cooling, the vegetables that you see are very, very shiny, very nice color. Rice. So everything for the airline is being vacuum cooled here in 20 minutes. Here you see, this is all the products, vegetables, the chicken, the rolls.
And this, Sylvia, they all go straight into packaging, right? Into their little meals for the plane.
Yes,
That's how.
yes,
Yeah.
yes. They cool this first, and after they take them out of the vacuum cooler, it goes straight to the tables where the people are dividing it in the small, the small packaging here, what you see here for the airline, correct?
Yeah. How
Yes.
many systems are they using? Because I guess they will have different racks, like different trolley sizes. Is that the case too?
No, they had like 2 or 3 vacuum coolers. I mean, in cooling in 20 minutes, they can do a lot per hour. So they have like 2 or 3 vacuum cooling systems. And then of course they have the blast chillers, but this is their main cooling system.
Yeah. Great. Okay, so let's go to the next case study, which is here in Australia, New
In
Zealand.
New Zealand, yes, we have a customer who is using vacuum cooling for cooling lasagna, and this customer is using special lids with some holes to avoid a bit of splashing, and they're now ordering a second system. These are systems to cool around 400 kilos of lasagna, also in about 25 minutes, down to around 10 degrees. So all this to speed up the cooling, speed up production. So yeah, next one. Esther, thank you. Now going a bit into the technology, here you see some models, and you see that actually a vacuum cooling system is composed of only 4 components. It's not a difficult system to say. We try to have it as simple as possible. You have the room, which is adapted to the trolley size of the customer and the number of trolleys he wants to cool at the same time. So you have the room in stainless steel, all is stainless steel. Then you have the vacuum pump. You have the heat exchanger, which is the most important component of the system also. And then you have the chiller. The control, the PLC, in the PLC, you can control the whole process. We have also a special regulation valve where you control the speed of the process if you would like. So for maybe a bit more products which are a bit more liquid, if you vacuum cool a bit slower, it can limit a bit the splashing. So we have the PLC where you can insert many different recipes. But as you see, for cooling food, usually it's more or less straightforward in 20 minutes, 25 minutes, going down to 5 degrees. But you can insert different recipes going down only to 40 degrees or 30, all depending on your process and the end temperature that you're looking for. In the next slide, you can see the system. You have the room, and you have at the side, you see another part where the technology is installed, which is the cold trap, which is the pump and the valves, and then the piping going out for the glycol to the chiller, which is always installed outside. Now, if companies don't have enough space in the kitchen, there is also the option that you only install the room in the kitchen space and the technology at a second level. And in the next, we have a drawing. Let's go to the next. Yeah, this one. Here you can see one of the options where you can install the technology on a second level. On the second level, you see the cold traps and you see the electric cabinet and the vacuum pumps. So this is just to show you options, but if you have space down, you can also just place it next to the kitchen, next to the vacuum room. If we go back, yes, here you see several models. We have the first one with the normal manual hinge door. It has a pneumatic ramp, and at the side, all the technology. We have also the option to lower the room in a pit in the floor so that the trolley enters much faster. It's much easier loading and unloading. So for this, we have a door with a pneumatic lifting device. You can also have the room with two doors, entering one way, going out in the cold room, also possible, or a sliding door. There you need a bit more space at the side, but they're all options we have. Now, in the next slide, you can see a system installed where all the technology is on top. So there you see the piping of the vacuum going to the second level, and you see the piping for the glycol. And again, here at the left, some pictures of products that our customers are cooling. Okay, so why Weber? Well, as I explained, we are worldwide present, and we focus on vacuum technology. So we have a very wide knowledge of what is the best configuration of the systems to really obtain the fast cooling times. We know exactly what vacuum capacity you need, what are the best pumps, and the best cooling capacity. The cold trap size is important to absorb all the moisture because you don't want any moisture in your pumps. So we have a very wide knowledge, which thanks to all the years of our experience, and we offer tailored solutions. So depending on your needs, on the weight of your product, the size of your trolleys, we make for you the room that you need for your kitchen and your space. We support customers from the very start up to the end. We advise, we have testing devices. Also in Australia, we have testing devices. So you can see with your own eyes, what does it do with my product? How fast does it cool? Are there any changes in taste or in structure, which is not the case? So you can just see it by yourself, and you can also have the demo for some time and do your testing in your kitchen. And because we work worldwide, we work with partners, and we have a strong network, local support, and in Australia, we have Heuch supporting you with all your questions and advising you. So yes, this next slide, Esther.
Yeah, in the meantime, just a quick reminder to everyone who is attending today, please feel free to start popping your questions in the chat. We are about to get to the point where we will have that live Q&A. So we have seen quite a lot already, so I'm sure there will be some doubts, something you would like clarification on, or more details. So please start adding those questions. Thanks.
Thanks, Esther. And here you see a small group of companies that are using our vacuum cooling solutions. Not only companies using for cooling hot products, but also we have a lot of bakeries. For bakery, vacuum cooling is exceptional. It's not only about rapid cooling, but also shorter baking time. So if you are interested, because I saw some participants from the bakery sector, we can have another webinar or meeting with you to explain. So airline caterings you see here are using it a lot. Also, many companies that sell sushi, they use vacuum cooling a lot, not only to cool the rice, but after, when they make the sushi rolls, they also cool the sushi rolls down to very low temperatures, to 5 degrees. So it's being used more and more because people are learning the benefits of vacuum cooling, which is the very fast cooling and also the longer shelf life and less risk of contamination. All really very big benefits if you compare to the traditional cooling methods. So I hope it was clear, our presentation about how it works, vacuum cooling, and please feel free to send us any questions you have. We'll be happy to answer with my colleagues Nick and Branimir. Thank you.
Yeah, so please, I'm gonna give everyone a couple of minutes to pop those questions in the chat. In the meantime, just to remind everyone that so at Heuch, we are here to first understand your needs, come to you, talk about what are your challenges, your bottlenecks, and how vacuum cooling can fit into your existing processes and help you improve them. So we more than welcome for you to request a quote. We also have a demo unit, like Sylvia mentioned before. We have used this to test how food works in different types of food. Maybe lasagna, it may be a sauce, it may be pasta. So more than happy to facilitate also a demo for your company. We also conduct what we call feasibility studies. Sometimes when there are various stakeholders involved, they are maybe not on the floor, they are not so involved in, they don't see the pain points that people in the operational teams do see pretty much every day. So these feasibility studies help those people who have to put the case in front of them with some figures. So we are able to show, for example, in terms of energy consumption, how vacuum cooling helps, in terms of cooling a lot faster, what those times look like. Once we understand the cycles that you run at your companies, the amount of product kilos. So that is something that we do most of the time when we put together these quotes and these systems. We also hire vacuum coolers. It's not really that common, to be honest, but it's an option that can be explored. and something else that I don't have here, but we have launched recently is leasing vacuum cooling or vacuum coolers. What this helps with is, often this is a large investment. So with leasing, it just helps. Not always. Some companies go through CapEx and they just get this approved and they just purchase the equipment. But leasing is also an option. So feel free to inquire about that. So yeah, these are our details. Feel free to send me an email directly, esterg@heuch.com.au, or just give us a call. But again, I'm hoping I'm just gonna go to the chat and hopefully there will be a few questions from some of the attendees. Let's have a look. Okay, so there is a question here in terms of moisture loss. How does that look for food? So Sylvia.
Yeah, so moisture loss, it depends on the product. What we see is it's very average that you can lose around 1% of moisture for every around 10 degrees you lower in temperature. This is a rough indication of moisture loss. Correct.
And I guess again, Sylvia, what we have seen from doing tests for vacuum coolers we have installed is that it really depends on the food, right? Like it depends on what they are doing. And that's why it is interesting to also do testing when we can. Okay,
Right.
so we have another question here. Do they require a lot of power to run?
No, it of course it depends on the size, but what we usually see is a very rough indication is 1 kilowatt-hour energy consumption for every 100 kilos. So if you have a trolley of 200 kilos, just calculate with 2 kilowatt-hour consumption for a cycle. It's very rough, but it gives an indication of the energy consumption.
Great. Okay. Any other questions? I cannot see any other for now, but anyone else would like to pop? Okay, so I would like to just quickly, so Nick, as I said before, he's the consultant for Australia, and he, you will see him coming with me if I can see some of our prospects. So Nick, is there anything else you would like to add, that relates specifically for the Australian market? I guess what we are definitely seeing, Sylvia said before, this is a system that is being used in turf, in bakery, but in the food industry, we are seeing a huge adoption here. It seems like it is the time, 2025, for that. So, but Nick, anything you would like to add before we finish?
No, just as you just mentioned there, that it is relatively new to food processing within Australia and New Zealand. So we recognise that there's a lot of knowledge gaps that's missing within the vacuum cooling sector. So we're very open with what we do and how we do it. So we're always available for questions. If you just want to explore the idea, if it's not something you're thinking about implementing in the next year or so, that's no reason to start getting in contact and get your knowledge base up. And we're always happy to have a chat and come and see your current operations, how you're doing things, and what improvements that we think vacuum cooling can be implemented for your business.
Yeah, exactly. No commitment whatsoever. We are more than happy to get in front of you, sit down and just discuss, what your challenges are and how we can help, and then just take it from there. So there is another question actually that just came through. How well does the cooling work on pies or pie filling?
So I can talk to that if you like.
Yeah, please go ahead.
So very well. We especially with the cooling curve that we've developed with a couple of bakeries that exist here within Australia. Obviously, pie consumption is very big here in Australia. As Sylvia was talking about before, it does tend to have a lot to do with the viscosity of the filling of the pastries. If it's a very liquidy content, we do tend to have some trouble with ruptures or splashing. But even in that circumstance, we do know where that's occurring within the cooling curve, and we can manage that. If it's a bit more viscous, it's just the same as any other product that would be cooling in a tray or on the shelf. We can definitely cool it down. It works very, very well. Just as an example, there's a bakery here in the Mornington Peninsula in Victoria that won the best pie in Australia competition with Good Foods, I think it was. That company is using our vacuum coolers, and he swears that the only reason they won that award is because they're vacuum cooled. So we're very proud of that, and he is too. But the answer is it does work well. I think we actually had a picture on one of the slides back there of his pies that were vacuum cooled. I think it's 4. It increases the sort of puff of the pastry and holds that shape as it does when it first comes out of the oven. So the presentation of the pies as well looks fantastic, and it holds its shape and structure for a lot longer and increased shelf life, less chance for microbial growth. There's a lot of benefits for vacuum cooling pies.
Yes, Nick, because also the cooling time is very short, right, for the pie.
You're probably talking, I think he's doing it in about 13 minutes. Cool it down to below 20 degrees.
Right.
And that would be from around 90.
Straight out.
Yeah, straight out of the oven. Yeah.
96, 97 degrees.
Right.
Yeah. So for bakeries, we are also, and again, we've done this before, so we are more than happy to also do tours. So luckily, this customer that Nick is referring to, he has always been really open. He's very well known in the industry here in Victoria, in his area in particular. So yeah, more than happy to take people who may be interested in, or who are interested, to just go and have a look. And they are also quite open to share what their experience is with using vacuum cooling.
Just on that, I realised that customer asked about pie filling too. So like the customer in New Zealand, they also cool their pie filling in Eurobins, which are specialised with the lid that Sylvia mentioned before. So they do big vats of pie filling, the gravy mixture. They cool that down a little bit longer time frame, but close to that 20 minutes, because they do big kilos at a time. But it also works with pie filling very well.
So we have another question, which would relate to really not only bakeries but any other industry, and we see this across turf and others. Is this scalable to large commercial volumes? This is specifically for bakery in this case, or food?
Are you happy for me to take that as well?
Yeah, look, I mean, I can tell. So we do, like Sylvia said before, we basically adapt the systems to whichever sizes the customer needs. What we really, the reason for this is because we want to make sure that the chamber itself is maximized as much as we can, so it gives the best result. So in terms of to large commercial volumes, we would need to sit down and see what volumes those are. But we have systems that go up to, Nick, can you confirm, like, to how many kilos?
Well, so for other, it's definitely scalable. For other industries that we do tons and tons of turf product. That's another industry that it's used for. They're doing 24 pallets at about 1.5 tonne per pallet, and they're cooling it down in about 30-minute cycle times. So in terms of scalability, it's mostly about the weight of the product that you're putting into the chamber. The sort of restriction that you have around then, funnily enough, is going to be your load times. How quickly you can load your hot product in and out of a chamber that's going to be 24 pallets big. In terms of food industry, we more want to think about what's the most efficient way to do that. So if we need to divide your productivity into, let's say, 3 chambers of 400 kilos each, that's something we put into consideration. If it's more feasible to do a different configuration where we can do 2 trolleys in one system that's operating while another trolley is getting loaded, that's the way that we'd look at it. But in terms of scalability, sky's the limit. It's mostly about us looking at the cooling capacity requirement of the product that's going in, and we can adjust our systems accordingly.
Okay, so for someone, just another question from an attendee. So for someone who doing approximately 250 racks per day at 200 kilos each, so in terms of systems, what would we be recommending? So that is 250 racks per day at 200 kilos each.
So there's a few factors that we'd have to take into consideration about how long is that shift? Is that over 2 shifts of 8 hours each? That 250 would need to know like the baking time or the cooking time, how many ovens they're operating with, so how many racks are coming out per hour. We'd then look at either 1 or 2 systems for that. I believe one system would easily be able to handle that sort of capacity at 250 kilos. You'd be cooling, every 20 minutes, plus or minus 10%, let's say, for loading or unloading, maybe closer to 5%. But the answer's it's manageable. That capacity is easily manageable, and I'd say with a single system.
Yeah, and again, this is where that feasibility study or just getting together and understanding all your specifics, about your operations would really help, and then we would be in a better position to really talk about what system would work best. Yeah, so we have another question here. So I am in the fruit and vegetable industry, looking at packaged vegetables. Would this work? So we have seen this where it's being used, vacuum cooling for vegetables that are then packaged, and they use it for so they don't have as much I guess water, so that doesn't affect the packaging. Nick, I believe, we have discussed this with other clients and prospects, so if you could just elaborate a little bit more.
So I'm not sure if this means packed vegetables, as in packed into a crate or like CHEP bucket or something like that. That's completely feasible. Let's take broccoli, for example. It also works with corn, mushrooms. So I assume this is talking fresh fruit and vegetable industry.
Yeah,
Yeah.
if you could, just clarify the person asking this question. If you could just let us know if you are referring to fresh pre-packed bags as well.
So it depends. Yeah. So packaged goods is a bit tricky, as Sylvia mentioned before. If you have any skin or any wrapping or any plastic that goes over the top of the product, the vacuum can't penetrate the core of the product and can't draw any heat and moisture from the product to allow it to cool. So if it's in packaged products, the vacuum cooling won't work. If you have a specialized designed porous packaging or plastic that is specifically designed for breathability, there is an option that it may be feasible, but again, you probably need to test the product to see how effective vacuum is in it. It is, and what effect it has on the actual packaging itself.
Yeah, we know from some customers that cool herbs in clamshell packaging, it works because the clamshell has like a small, it's not tight, so the moisture can go out. So it is possible as long as the holes are not so small. So yeah, it all depends on the packaging, but it is possible.
Yeah.
So there is another question. In terms of bread, how does vacuum cooling differ for a standard loaf bread versus the artisan type of bread? So how does it work for either your standard loaf as opposed to the artisan?
So vacuum cooling with bread is very, very different to food and food processing. Food tends to be a bit of a longer cycle. Bread you can do very, very quickly. So we're talking between 3 to 5 minute cycles, depending on the weight and variety of the type of bread. Something like a standard loaf or tin bread It works perfectly with, you can put it straight from the oven into the vacuum cooler, maximum probably 5-minute cycle, as long as it's not gluten-free. If it's gluten-free, there's a bit more care that we put into the structure of the bread, because it'd be quite volatile. But yeah, about 5-minute cycle, and then you can depan immediately after vacuum cooling.
And the key here is that it just works with both. So it works with with artisan bread, with your sandwich bread.
Sourdough loaves, any sort of small pastries or danishes, it works fantastically well. With breads as well, typically you'll lose about 15% of your shape and structure just because of the natural collapse you're going to get after it comes out of the oven fresh. With vacuum cooling, you don't lose any of that shape and structure. It maintains that because you've cooled it down so quickly, the structure of the bread doesn't have a chance to collapse in on itself. So it keeps that quality up there. And same with food, it removes chance for microbial growth to occur. So bacteria is just diminished.
Actually, just a short explanation on bread. It's amazing, and it's different from all the other applications because you generate steam during the process of vacuum cooling. That steam helps also to enhance the process of what the bakers call the process of gelation, so starch. So it's like you are cooking your bread further. So that means that while you're vacuum cooling, you're also continue the cooking of the bread. So you have to shorten your baking time to lose also less moisture. So on the one hand, you have a very, very fast cooling time for bread. It's really minutes, 5 minutes, 6 minutes. And then you need to shorten your baking time. For thin bread, it can be around average 30%. So it's not only about fast cooling, it's about saving a lot of time in the oven. So that's one of the main benefits of vacuum cooling for the bakery.
Yeah, particularly at scale as well. That's a fantastic point. If you have 5 ovens operating at, let's say, 60 minutes per cycle, and that's 6 cycles per day, if you reduce every one of those by 30%, that's, you can save hours, literally hours of production time per day. Just in baking, that's putting cooling aside, that's just in baking time.
But glad if somebody wants a separate Teams meeting to explain a vacuum cooling of bread, please let us
We
know.
may have to have another webinar on bakery. I think that'd be called for.
Yeah, exactly. We do have we ran one on bakery not long ago. So yeah, we will send an email after the call with a few resources. So yeah, please head over to those with case studies, brochures, and links to webinars. Okay, so are there any other questions before we wrap up? It's like I'm conscious of the time. I know everyone is a bit short with their time, and it is 3 minutes past 5. So okay, well, we are gonna finish here. Thank you so much again for everyone who attended. I really hope that you found it really insightful, and please get in touch. Again, more than happy to meet with you, have a call, whatever is best. And explore further how we can help your specific operations.
Thanks, everyone.
Thanks, everybody, for attending.
Thank you. Thanks.
All right.
Bye.